Hi everyone. So, welcome to Graphing with Miss Stewart. So, today we're going to do your homework assignment together to make sure that everyone feels comfortable with graphing for as much as you need to know for both this assignment in general in life and for the lab that's going to be your mastery assignment in a few days. So, to begin, there are a few big ideas that I want everyone to know, so we're going to write them along the edges of the graph. So the first thing is that we have to figure out, is the information that we're looking at going to be something that should be a line graph, a bar graph, or a pie chart? So when I look at this information, the question is, am I looking at a lot of different things that I want to compare to each other? Or am I looking at one thing and that same thing at a bunch of different times, like either years or hours? Or am I looking at a whole and trying to figure out how many parts each one has? So if I'm doing a comparison, that would be a bar graph. So what are we writing for our big ideas? Bar graphs compare information. For line graphs show change over time. And pie charts are when you want to see the parts of a whole. So pie chart equals parts of a whole. So how does that look on my paper? Da-da-da. Bar graphs, right, and all the way across. So the next thing is when we look at this, our homework, we're seeing one thing, the prevalence of diabetes, and we're looking at it over time. So I'm deciding this is going to be a line graph for sure. So I have all these dates, and I have the number of percentage of people that were diagnosed with diabetes. So now I have to decide what goes on my x-axis, what goes on my y-axis. Well, this is where I use my title to help me. So it says diabetes in the United States. So I'm looking at the percentage of people diagnosed by the year. So what I'm really talking about here is I'm looking at dates over time and how many people have it. So my dates are really important, and they're the subject of my graph, so they're going to be the x-axis. So take a moment, starting in 1994. Now I recommend don't start your first number like right at the edge of the graph, because then you have to graph on that line. I recommend going one in. So starting from one box in, I'm going to go 1994, 1995, 1996. And the question is, do I skip one or do I not skip one? Well, the way that I do that is I look and I see I've got from 1994 all the way to 2013. So that is like 19 years. So do I have enough room across the bottom to do 19 boxes with a space in between? Not really. So I have to just do each date is its own line. Now then the question is, for a bar graph, I normally put the subject right under the space of the graph, but with a line graph, I'm labeling the individual line. So this line is going to be my 1996 line. So I keep going, and I put one date per line all the way up to the 18 years that I'm looking for. So 1994, 95, 96, 97, 98, 99, 2000, 2001, 2002, 2003. So I make my way up the graph until I have labeled each of the lines. Now the thing is, I'm labeling the lines. I'm not labeling the axis. The axis is what do these numbers mean? So these numbers could mean 2002 elephants. But no, they're actually dates. So you would put dates in years. So dates in years is my x-axis label because it tells me what I'm talking about and it tells me the units that I'm talking about it in. So dates in years. I have to finish this 2006, 2007, 2008, all the way up to 2013. So I'll do this with you. Okay. So I have my dates across the bottom. I have labeled my x-axis. So that's a very important thing. So put a star next to it and we have a reminder. Label the x-axis. So I'm reminding you to label the x-axis because that is an important detail. Then the next thing is picking the numbers up the side. This is where most people get stuck. So you want to think to yourself, okay, how do I know? Do I count in ones, fives, tens? They always have to be the same amount of numbers between each line. So you can go 5, 10, 15. You can't go 2, 15, 23, 75, because that doesn't make each box worth the same amount. So your graph is really hard to read and it doesn't make sense. So instead, the big idea, the thing I want you to know, is that you look for your smallest number. In this case, we have 4.4. And you look for your biggest number. In this case, we have 9. So 4.4 is my smallest amount. So anything below your lowest number, you don't really need to graph, especially if your lowest number is really big, something like 200 or 2,000. Then don't start at 1, 2, 3, because by the time you get to 2,000, the graph is, you're way off. So instead, you can make a break, which is that little squiggly line on the y-axis. So I can do that so that a nice even number that is below my lowest number, but something that doesn't waste a whole lot of graph space, would be starting with 4, okay? So I have my little squiggle, and then I start with 4. Squiggle, start with 4. I know everything's backwards for you, sorry about that. I hope it's not too big of a problem. So, my backwards squiggly 4, which hopefully is forwards for you, that's where we start. And now we're going to pick something that we're going to count up. And the idea of picking your intervals, which are the numbers on the y-axis, the big deal is you want a small enough number that you can really see the detail between your numbers on the graph, but it's not so small that your top number would go all the way off the graph. So I want to count by something really small and still make it to 9 before I'm off the top of the graph. So I think I could count by 0.2. So 4.2, 4.4, 4.6. It looks like maybe I'm gonna run out of space. So I'm like, okay. So sometimes it's worth redoing and checking it and seeing how many boxes you have. So maybe I want to go up by 0.5s. So 4.5, 5, 5.5, 6, 6.5. Now you might wonder, why didn't I just go up by ones? Isn't it easier to just do ones? Well, the thing is that when I look at my numbers, the difference is in the detail. And the more I can represent my detail on my graph, the more useful the graph is, the more I can see change over time. So I go up 7, 7.5, 8, 8.5, 9. So our big ideas: skip to a number just smaller than your lowest number you have to graph, and then pick an interval that you're going to count by that is small enough to show as much detail as you can, but big enough that you hit your biggest number before going off the top of the page. So every time you start a graph, what are you going to do? This is the big idea. So you look for the smallest number, and that's going to be the bottom of your graph. You pick the biggest number. You want to make sure you get to the end of the graph before going off the page. And then think, what can I count by that can give me the most detail possible to like spread out those numbers as much as possible to really show detail. So from there, you just need to match the date to the number. So I have my first year. Sorry, this is backwards for you. It's totally annoying, I know. 1994. And then it says 4.4. So I'm going to put a dot just below the 4.5. And I see for 1995 and 1996, it's the same thing. So I continue to make my dots. In 1997, it goes to 4.7, so now I'm going just above my line of 4.5. And 98, I go just a little above 5 to 5.2. So you can still show gradation on your graph and detail by going between the actual lines. So see how my 4.4 is just below, and then it goes up from there. So I'm going to continue to place my dots on the line of the date and as close to the right number as I can get it relative to a 0.5 scale on the side. So hopefully this helps. Everybody that's doing the easy version of the graphing, you just continue your dots and connect them with a lovely ruler, or just, as close as you can with your hands, that works. So our big ideas are figuring out your intervals by looking at the smallest number and the largest number and picking an interval that is as small as you can, but still gets to the top of the graph before you hit your biggest number. And we're not going to forget our labeling our axes. So you want to label the dates in years across the bottom for your x-axis, and then these numbers up the side are the percentage of persons diagnosed with diabetes. It tells it to you on the data table, and 9 times out of 10, whenever we have a data table, you have your x-axis on one of the columns and your y-axis on the other. So I'm going to write up the side of my y-axis percentage of persons diagnosed. So at this point, you should be almost finished with your homework assignment in under 15 minutes. Congratulations. So for those of you who would like to continue, please check out part 2 of this video for the challenge section. All right, have a good night.